Welcome to Mitchel classroom by Mr. Africa. Today we're going to learn what's in an atom. For Dalton, atoms were simple, indivisible, tiny spheres. We have seen that to understand the way matter is made, we need to consider the way in which atoms are bonded together. Dalton did not have any explanation for this, and so work went on to try to understand better how atoms could join together. The first clue came in 1897 when British scientist Joseph John Thomson experimented with a new discovery called the cathode rays. Cathode rays were mysterious energy that seemed to be emitted from some metals when they were heated and electrically charged. At first, many thought the rays were pure energy like light, but Thomson had the idea that they might be caused by particles and that these particles streamed away from the electrically charged metal because they also had an electric charge. The cathode ray tube experiment. Cathode ray tubes are sealed glass tubes from which most of the air has been evacuated. A high voltage is applied across two electrodes at one end of the tube, which causes a beam of particles to flow from the cathode, the negatively charged electrode, to the anode, the positively charged electrode. The tubes are called cathode ray tubes because the particle beam or cathode ray originates at the cathode. The ray can be detected by painting a material known as phosphorus onto the far end of the tube beyond the anode. The phosphorus spark or emit light when impacted by the cathode ray. Now, in order for J.J. Thomson to test the properties of the particles, he placed two oppositely charged electric plates around the cathode ray. So there's the positive and there is the negative one. The cathode ray was deflected away from the negatively charged electric plate towards the positively charged electric plate. This indicated that the cathode ray was composed of negatively charged particles, hence the discovery of a subatomic particle which he called the electron. Thomson reasoned that atoms should not have an electrical charge overall. Otherwise, matter would be affected by electric fields. Consequently, he hypothesized that the atom was like a plum pudding, with a positively charged sphere and a negatively charged particles. It seemed that atoms were not, after all, uncuttable. Proof of the hypothesis came in 1911 when New Zealander Ernest Rutherford asked his research assistants Geiger and Marsden to carry out an experiment. The experiment was intended to estimate the thickness of a piece of gold leaf by firing another new kind of ray consisting of alpha particles at the gold. Rutherford was expecting that the plum pudding atoms of gold would cause the rays to deflect away like two balls in a game of pool. When calibrating their equipment one day, Geiger and Marsden noticed that some of the alpha rays were being bounced right back in their paths. Rutherford realized that this meant there must be a very strong force between the alpha particles and the atoms of gold. The only force known to be capable of doing this at the time was the electric force. Rutherford then deduced that there must be a very strong electrical charge inside the atoms. When he carried out his calculations, Rutherford saw that the electrical charge of the atom would have to be condensed into a very small area, much smaller even than the overall size of the atom. He called this the nucleus, and the atomic model was revised again. Now, I will be explaining Rutherford's gold foil experiment. So, Rutherford, together with Geiger and Marsden, they did the gold foil experiment to test the plum pudding model if it's a good or a correct representation of what the atom looks like. So, what they did is they used a radiation source, in this case radium, which carries an alpha particle, and then enclose it in a box with a tiny hole so that the particles or the beam can pass through it. And then they beamed the alpha particle or the radium in gold foil and uses a detector here around. So what happens is that the alpha particle beamed through the gold foil and some of the rays passes through, some deflects a little, and some bounces back. So what are their observations? They observed that most alpha particles travel through the foil undeflected. So the atom is mostly empty space. Also, they observed that some alpha particles are deflected by small angles, which means that the nucleus is positively charged, as is the alpha particle. And there are some rays that bounce back, which means that the nucleus carries most of the atom's mass. So through this gold foil experiment, Rutherford, together with his research assistants, then found out that there is a dense material inside the atom, which he called the nucleus. So in summary, we studied about John Dalton and his proposal that atoms were simple, indivisible, tiny spheres, and how J.J. Thomson challenged this by his plum pudding model, hence the discovery of the electrons. And lastly is Ernest Rutherford and his gold foil experiment and the discovery of the nucleus. Thank you for listening and have fun learning.